So I'm Ashraf Murtada. Thanks, Patricia, for the introduction. I'm going to talk about artificial intelligence, what really is artificial intelligence, trying to demystify the technology and what it really means, and also shed some light on practical points around how to implement AI in organizations. I'm a self-confessed geek. I'm a computer scientist and an engineer by education. Spent a couple of decades around software engineering, data analytics, and technology leadership. I currently lead a large-scale engineering function within HMRC, leading on their data engineering capabilities, their analytical capabilities, and cognitive things, as in AI and machine learning, and so on. Okay, so AI, we hear about it a lot these days. There is certainly a lot of promise from the technology, and lots of companies and organizations are eager to kind of unlock the value that the technology brings. However, with all the complexity and loads of hype as well, and the level of maturity within the field, within AI and machine learning, are organizations actually seeing success in trying to implement AI and machine learning in business and deliver real value or not? That's the key question. A recent FT article kind of sums this nicely. It says everything is still to play for with AI in its infancy. The document or the article references the different approaches two giants like IBM and Google are taking to doing artificial intelligence and implementing artificial intelligence in terms of practices, in terms of engineering approaches, and so on. IBM CEO talks about AI being random acts of AI, and Google Cloud, the head of AI for Google Cloud Business, talks about artisanal AI. It kind of talks about the hit and miss nature of applying AI in organization. It talks about the level of skill and the level of specialism that is needed to implement or achieve the right outcomes for the business. Let me just calibrate a little bit. So in this room, how many people in this room run an AI company today? No one? Okay. How many in your organization say that you can actually say that you have an AI strategy? When it comes to AI strategy, do you know what you're doing? You've got an AI strategy, you've got a team, you're starting to work on it. Anyone? So there is one. Anyone who started working on AI, putting a team together, but not yet actually sort of driving forward and have a vision? So a few more hands. And how many you would say want to do something with AI but just don't know where to start? So typically, most people who got an interest in the field say they're just starting to see how they can get started and want to implement something. Who in the room is able to confidently and succinctly in a few sentences say what AI is? Right? There are many different definitions of it. If you just Google it, you'll find lots of different definitions. One sort of generic definition is AI is the pursuit of performing tasks by the machine that are usually reserved for human cognition, like recognizing patterns, like predicting outcomes, or making decisions even. That's the type of stuff that you could call AI when the machine is able to do that. And here are some quick examples of AI in use today. So you've got recommendation engines like Netflix and Amazon. I believe most of us in the room will probably be using both of those things or one of those things. And when you log on to Amazon or you log on to Netflix, it hits you with a number of recommendations based on past interaction with the system to tell you might be interested in watching this series, you might be interested in watching that movie. And the same thing for Amazon when it comes to things that you might want to purchase. Autonomous cars, we've seen a development. Quite a lot of developments in that space. Virtual assistants on our phones. Our phones have lots of AI capabilities in our pockets. Robo-journalism. If you've come across this, there are figures that are quite scary about the number of articles on the internet that are actually written purely by artificial intelligence. Summarizing like sports events or press conferences and things like that, and just putting the content published out there as if it was written by a human writer or human author. Scary looking robots from the likes of Boston Dynamics and so on. Lots of AI applications over there. Even music composition. Sony Labs have created an AI tool that actually was able to compose 2 complete songs start to finish without any human intervention. They are available on YouTube. Look them up. If you Google them, you'll find them. Lots of applications in the medical field, allowing or enabling medical professionals to be assisted in the diagnosis or surfacing relevant information for the medical professionals to make a better judgment about the diagnosis and so on. And we've probably interacted with chatbots and sales bots and things like that that we thought might be talking to a human instead. Okay, so we've just presented a definition, a generic definition of AI. What I want to focus on for a few minutes is an economic perspective on AI, which is a different perspective. It might seem a little odd, but it's going to give us a really simplistic definition of what AI is, distill the complexity away, and tells us what AI really means from a business perspective. And it will also give us insights as to how we apply AI in businesses. Let's cast our minds back to 1995. AI today is pretty much like the internet back in 1995. That year, 1995, was a key year for the internet. The internet at that point in time existed probably for about a decade before then, but solely in the military, used in the military and used in academia. But 1995 saw some key events that made the internet so widespread. Windows 95 was released by Microsoft. NSFNet was decommissioned, paving the way for commercial traffic on the internet, not just academic or military traffic. Netscape, web browser, anyone old enough to remember that? Brilliant. It IPO'd in 1995 for $3 billion without making a profit, right? All of these things were some of the factors that propelled the internet for widespread adoption and use by everybody, and for commercial use and personal use. Everybody, because of the wide reach of the internet, started talking about the internet, stopped talking about it as a new technology, and started talking about it as a new economy. Except one group, economists. They said nothing changes about the internet when it comes to economics, because the laws of supply and demand still the same. The laws of production and consumption still the same. The laws of pricing and costing is still the same. We don't need to change a single word in a text box, in a textbook, that in order to describe the impact of the internet on our society and on our lives. Now, there is one thing that has crucially happened with the advent of the internet. Not the laws of economics. The laws of economics did not change. What has changed is the cost of certain factors or inputs have fallen dramatically because of the internet. Examples being search. Search, you can go on a search engine. Even back in 1995, you can go on the internet and search and find content and find products. Products can find consumers as well. So search all of a sudden became a lot more cheaper than before. Distribution is another example. You can now distribute goods digitally, which is a far different approach and at a very different cost point compared to physical distribution. And we started doing the same thing for other things. We started impacting on other aspects of our lives because of the internet. It reduced the cost of so many different things. That's why it was so prevalent and people thought about it as a new economy, but it wasn't. But it turns out finding, for any type of technology, pick the one you want, what that technology reduces the cost of gives you very valuable insight as to how to apply it. Where do you actually get the most value out of it? Okay? Let's take Silicon Valley as an example. The best thing to describe Silicon Valley when it started is obviously the semiconductor industry or the microprocessor industry. The creation of processors in our computers, personal computers to start with, and then all of the other devices that we use. If you ask a computer scientist to describe the rise of Silicon Valley, or more specifically the semiconductor industry, they would start talking about circuits, designs, the number of transistors on a microchip, the Moore's law and the doubling of processing power every 18 months, all of those things. That's what they start talking to you about when they try to describe the rise of the semiconductor industry. If you ask an economist to describe the rise of the semiconductor industry, they will show you a graph similar to this one. What this shows is the drop in cost over time for something because of that technology. And in the case of microprocessors or semiconductors, that thing is arithmetic. The cost of arithmetic has become all of a sudden very cheap. We used to have computers well before the computers that we use every day today have been invented. It was a role, it was a profession. People who did computations well, people who did calculations well. We actually had people doing those things in the likes of NASA, census offices, and the military. Now, arithmetic cost has dropped because of semiconductors and microprocessors. And when the cost of something drops, three important things happen. Very important things happen. The first one is captured in this diagram, which is what's called in economics a downward sloping demand curve. When you have something dropping from cost P1 to P2, the demand for it increases. Something gets cheaper, we simply use more of it. We demand more of the cheaper thing because it has dropped in cost. So the first thing is when something gets cheaper, we use more of it. Probably at this point you will say, this guy said he's going to talk about AI. What has anything of this to do with AI? Bear with me, we'll get there. Okay? So the first thing that happens when something gets cheaper, we use more of it. But there is something more profound that happens. Anyone old enough to remember the films that we used to use in our cameras to capture pictures, essentially? Photography at that point in time was a chemistry problem. We exposed the film with a certain set of chemicals on it to light to capture the picture through the camera. And that's how we captured pictures back then. So it was originally a chemistry problem to produce a picture. With the advent of microprocessors and cheap computing, we had a drop in the cost of arithmetic. We started capitalizing on that and converted photography from a chemistry problem into an arithmetic problem. We started creating digital cameras. We started doing this for everything. We started to have digital music, digital banking, digital everything. We started digitizing everything because it became a lot cheaper to do arithmetic, became a lot cheaper to do things digitally. And that's a profound thing. When something gets a price reduction, a significant price reduction, we start to actually think, how can I do this bit here, which I haven't traditionally done in that way, in this way, because it's cheaper. There is much more value in doing that. Okay? The second thing that happens when the price of something drops is the cost of complements goes up. And the third thing that happens is the cost of substitutes goes down. And I'm going to talk about a very simple example. The simple example here is coffee. Let's assume all of a sudden, for some reason, the cost of coffee drops. We will start using more coffee. We will start consuming more coffee. That's the first thing that happens. The second thing that happens, the cost of complements to coffee goes up. Cost of milk, the cost of sugar, the cost of coffee cups that we use because we are buying more coffee. There is more demand for these things, so naturally the cost of those things goes up. This is called cross-price elasticity. Now, third thing that the cost of substitutes goes down, in the example of the coffee, maybe tea is now less in demand as an alternative to coffee or other drinks, so the cost of it drops because of the subsiding demand. Okay? Now let's apply the same logic to AI. Back to AI, you're probably pleased to know. Okay, so let's apply the same logic. If you ask a computer scientist to explain the rise of artificial intelligence, and by the way, AI isn't new. It started rising again. For those of us old enough to have had exposure to AI back in the 50s and 60s and 80s and 70s, believe it or not, the first time AI was spoken about was in the Dartmouth workshop in 1956. So it's not particularly new. But if you ask someone today as a scientist, as a computer scientist, to explain the current rise of AI, they will start talking to you about neural networks and deep learning and the various algorithms and technologies and techniques that people are using. People will start talking about the vast amounts of data that are allowing us to enable AI in terms of training the AI models and so on. Don't worry, I'm not going to go into technical details of what this means. But if you ask the same question to an economist, explaining the rise of AI, they will again show you a slide like this one, a graph like this one, showing the drop in cost of something over time. And you can see, roughly speaking, there 2017 was a key year where we've had some key advancements in AI where we actually saw the cost of something dropping because of AI. Hold on to that thought for a sec. AI is so special. Why is that? Economists call AI a GPT, or a general purpose technology, meaning it has a very wide applicability. If you go to a big technology conference where you have lots of exhibitors, lots of technologies, you'll find lots on display. cloud computing, mobile computing, blockchain, IoT, virtual reality, augmented reality, you name it. There's loads of new stuff that's coming out. But AI is in a league of its own. Look at this Gartner survey from late 2018, I think it was December 2018, surveying CIOs, where it shows the inputs from CIOs talking about what they think are the types of technologies that are going to have the biggest impact on their organizations in the next 3 to 5 years. And they said the two top ones, artificial intelligence, machine learning, and the next one is data analytics, more specifically the advanced edge of data analytics around predictive analytics and so on. And that is quite a lot for the two top bars, representing about 45% of all of the spectrum in there, as having a significant impact on organizations. That's because of their very wide applicability. So why is AI so special? It's because with the case of AI, the cost for which the thing has dropped is such a foundational input to so many things that we do in business, whether we realize it or not. And in the case of AI, that thing is prediction. Yeah? This is a key point. This is a key point. The drop in the cost of prediction is a key thing we do in everyday business activities. We predict things as humans, we predict things with our programs on machines and computers and so on. So essentially what we're saying is AI equals cheap prediction. And think about this for a moment. If you're reading an article or a book about AI, just try replacing the word AI for cheap prediction, and that text will all of a sudden become a lot less magical and a lot more practical, because it reduces the cost of producing predictions. Okay, how does that help us? It means because prediction becomes cheap, we'll use more of it. Like the a massive increase in power from microprocessors and the massive drop in their cost have enabled us to digitize everything. The advent of AI, giving us the ability to do cheap prediction, will allow us to do prediction everywhere. And we'll start using more prediction. We'll start converting non-prediction problems to prediction problems. Remember the photography example I've given? Changing a chemistry problem into an arithmetic problem. Now we're changing a non-prediction problem into a prediction one. A good example is autonomous cars. Autonomous vehicles existed for a long time before the ones that we currently see partially autonomous on the roads today. They existed in industrial settings, in warehouses and factories and so on, within set constraints and controlled environments. They existed a long time ago, but they were achieved using rule-based programming of those devices and those vehicles so that they can navigate their environments. What Google has done with autonomous cars is they've converted it into a prediction problem and took a completely different approach. You cannot possibly put an autonomous vehicle on the open road and expect to have a finite set of rules to be able to tell it what to do. It's just not possible. So what Google did said, I'm going to put a human driver in the driver's seat, and I'm going to put an AI model in the passenger seat and let the AI model try to predict what is the best action that the human driver is going to do in a given situation. And if you think about it, it's like turn right, turn left, accelerate, or brake. You can kind of reduce the number of actions and things that the AI is being asked to predict as it needs to do in a given situation. And after miles and miles and miles of watching a human driver do the driving, the AI started to learn. At the beginning, it was rubbish. It was producing completely irrelevant outcomes and completely irrelevant predictions. But because it was cheap to do all of this, they've managed, with converting autonomous driving into a prediction issue, predict what is the next action to do, they managed to create the autonomous car business that we know Google has today. Okay? Right. What does that mean for our businesses today? We've had a journey on the economics of AI, a bit of a tangent, you might think, but let's see how can we apply this in our organizations today. Let's start with a little bit, zoom out a little bit. Data natives versus digital natives. My now 7-year-old boy, when he was around 4, he used to go up to the television screen and try and tap on it, thinking it's a touch screen. I think lots of our kids have tried to do that. For him, every screen is a touch screen. You might have seen the YouTube video of a little girl with a paper magazine. trying to zoom and pinch and swipe and thinking the paper magazine was broken, thinking it was the natural way that the magazine should have behaved. So digital natives grew up expecting everything to be interactive, expecting everything to be digital, expecting everything to be responsive. Data natives, however, take it up a notch. Data natives expect things to be context aware, to be personalized to their own needs and moments in time, and they expect things to be intelligent. Data natives don't expect a thermometer to be programmable, they expect it to program itself using data to learn. That's the distinction. And if you're building an AI strategy for your own business or your own organization, you want to think that far ahead. You don't want to automate stuff that is basic. You want to be able to think about use cases for your own products and services, or even new products or services if you're kind of creating a new business or creating a new set of products and services for the open market. You want to target those use cases where you're dealing with things at the level of the data natives rather than the digital natives. That's where you want to set the bar. Practical terms, how do you actually start doing AI? AI product management. We've got a very simple Venn diagram where it says your product managers need to think about what users love. This links to the previous slide. You want the data native end of the scale rather than the digital native. On the other side, you want engineers to think about what is technically feasible. And obviously, what needs to be delivered is the intersection of those two circles. This looks like stating the obvious. There's nothing special in here. But the left-hand side of it is kind of easier to imagine, easier to pin down, easier to define. With the current state of AI, its maturity in terms of practices and what we do from an engineering point of view, the right-hand side of it isn't that easy to grasp or understand or pin down. What is technically feasible? It's not always easy. You've seen the very first slide about IBM and Google, artisanal AI, random acts of AI, hit and miss approach to AI is still immature in terms of how we do it. So it's essential to know what is technically feasible. Andrew Ng, the renowned Stanford academic for AI, a couple of years ago, he said, anything a typical human can do in 1 second of thought, we can probably now or soon be able to automate with AI. Okay? That's a really good rule of thumb. Don't run away and go back to your offices and think, let's look at my business process. Everything that is done with 1 second, I'm going to automate now. Not just yet. But this is a good starting point. You can also try to automate tasks that humans can do today. Yeah? I'll come to the point about workforce and displacing people and that type of stuff. Why you need to start with tasks that humans can do today is because you know it's feasible. That's something about feasibility. You know the task is doable with a human mind. Because humans are doing it now, then you must have some data around it, which is crucial to be able to train your AI models. And then you can gain insights from the humans who are doing the tasks to fine-tune your AI models, to correct them, to monitor them, to make sure they're not biased, and so on. And as a rule of thumb, you want your AI model to outperform the human performance in that particular task so that you actually get a net benefit for your business when it comes to applying AI. Okay? Right. Let's look at this slide. And I think this slide probably, if you go away with one thing from this meeting, pay some attention to this particular slide. This is a very simple way of analyzing any business task. And you could break down any business task that you currently have in your company today into those components. Inputs, prediction in the middle. So let's take an example. So I'm going to do, I don't know, some financial analysis. I need some input into it. I start doing some calculations or thinking about it, and that's where the prediction comes into play. That prediction is also influenced by my past experience and training and knowledge that feeds into the prediction process. Once the prediction process gives me a number of outcomes or a number of things to go by, I then use judgment to choose one of them. And once I've chosen what I need to do, then I go into action. The action produces an outcome, And at best cases, that outcome is fed back into my knowledge and training. Now, where does that help us from an AI perspective? We talked about AI being cheap prediction. So AI sits right in the middle of that diagram. How does that impact on our workforce and processes and so on? We can use AI to automate the prediction components of any task, but not the judgment and not the action. And that's where the value add is from the workforce, from a human workforce, where you can use the human workforce for the judgment and the action and curating the training and so on. Now, remember that what we said about the cross-price elasticity, things, cost of something dropping, other things happen. The cost of prediction dropped. We spoke about that. Inputs are complementary to prediction. We are now using more prediction. So inputs to prediction are complementary now, meaning that all of a sudden, all of the data in our organizations are far more valuable than they used to be. Far more valuable, because you can use them to train AI models to do automated prediction. That's why people talk about data now being a corporate asset that actually needs to be on the balance sheet. You need to put your data, if you've read the book from Doug Laney, Infonomics, think about data as an asset that actually needs to be determined in value and put it on your balance sheet. So data becomes a lot more important because it's an input. Training becomes a lot more important because it's an input. So it's a complementary thing to prediction. Human prediction as an alternative to AI prediction will drop in value. And that's where the displacement is going to happen in terms of the workforce. While in terms of where you get the most value is to get your human resources and your talented teams to do the judgment and to do the action. That's how you can start applying AI in your organization. Take this down a level. You have your organizational workflows or processes broken down into tasks. We've just seen what's inside each one of those task boxes on the previous slide. Yeah? You can see those decision points in the third layer. This is where your AI going to sit at this stage. You're not going to wholesale automate something start to finish with AI replacing entire roles and entire teams. You're doing very targeted automation of prediction steps and decision steps that will give value to the business without having to do wholesale automation of all of your business processes. Am I doing for time? Right, okay. Setting up for success. So what does it take to implement AI in an organization? Let's use a quick analogy. A retailer, a normal traditional retailer, brick and mortar retailer with a website does not make them an internet company or an e-commerce company. I think we agree on that. There is a different mentality, different mindset, different business models, different thinking. A traditional company plus some machine learning models does not make them an AI company either. It's the same thing, okay? What you need for an AI company is a strategic approach to acquiring the data you need, the valuable corporate data assets you need from within your organization, from outside your organization to be able to do your AI well enough and targeted enough. You need unified data warehouses. I'm not going to go into the technical details here, but you just need a way in your organization, one way or another, to tap into the disparate data sources that you've got in your organization, because AI and data are two sides to the same coin. You need lots of data to train AI, and you need AI to make sense of lots of data. So that is very important to be able to access and tap into the organizational data assets that you've got. You need pervasive automation, like we were saying. Don't automate everything, not wholesale automation, pervasive. Everywhere you can actually externalize a bit of prediction point or a decision point, automate that. That will bring value to the business. And then we need to rewrite traditional job descriptions. And I'm going to focus on this one with the next slide. I'm going to skip this one for a sec. Rewriting the product manager job description. Think about how we do software development today. A lot of us are in the IT space. We have agile teams, we have developers, we have business analysts, and so on, and we have probably product owners or product managers. If you want to write the requirements for a chatbot, which is a form of AI, what do you want that requirement to be captured as if you want to give it to your AI engineering team? Is it going to be a mock-up like this? Is it going to be a wireframe? That's not the case anymore. You don't need the interface. You need the semantics behind the conversation that's happening within the wireframe. That's a very different thing to capture from a product requirements perspective to be able to give it to the engineering team. Another example is autonomous cars. A schematic like this does not help an autonomous car engineer to do anything with autonomy about the vehicle. They need to communicate through data. We need a shift in the way we do product management and product requirements and communicating that to the engineering team and back and forth as well, compared to the current engineering practices in software development today. Okay, that's very important. There is a shift in how we define our business roles in this area to be able to be effective. One quick thing about where do you put your AI capability in the organization? AI is a niche area, still emerging, still immature. It needs to be a center of excellence in its own right. And you need to be able to matrix in your resources into the wider line of business, areas of your organization from that org-wide AI team. And you need common platforms and common technical capabilities to deliver on top of that. Okay? I'm going to skip this one. Just a few words on strategy. Disruption is on the horizon with AI. It's increasingly touching almost every aspect of our lives beyond our imagination. And it is so far more common than we probably think when it comes to how it's being used today everywhere. What does it mean to be an AI company in this world? So cast your minds back to the recommendation engine that we talked about, Netflix or Amazon. Amazon, you log on to Amazon, you get presented with 10 items that Amazon thinks are relevant and interesting to you that you might want to buy. At the moment, probably the accuracy is about 2 or 3 out of those 10 items are relevant and you might have an interest in. You might check a couple of these and might buy one item. Okay? They continually try and turn the dial up to increase the accuracy of their AI to the point where currently the model is you go and shop and the goods get shipped to you. So it's shopping, then shipping. Okay? They can turn the dial up if they continue to increase the accuracy of their AI to the point where it reaches a threshold where it becomes business feasible for them to turn the model on its head and say, I know for a fact that 6 out of those 10 items is certainly of interest to this individual. I'm going to do shipping, then shopping. They'll send stuff to your doorstep. You will pick the ones you want and send the rest of it back, increasing their share of your wallet, essentially, instead of going buying out from another supplier. We don't know, obviously, if this is going to happen or not, but have a look on this patent filed in 2013, where Amazon filed a patent for anticipatory shipping. So it might happen, it might not happen, but this is what AI-led companies, AI-first companies think when they're trying to build AI capabilities into their organization, and the type of use cases they're targeting, where they constantly turn the dial up until it turns the business model on its head and opens up entirely new possibilities for the organization. Thank you very much.